So welcome to the day 7 of the weekend series, right? For Azure AI uh, session. So in this session, we are going to make sense the custom vision with Azure AI and how to train and deploy the model of our, for the own images and how to classify by using the custom vision. So here I am Jay Surya. I'm a Microsoft certified AI engineer and global speaker, and I'm an data analyst and data analytics specialist, Gen AI, and I'm working on multiple projects. So here you can see the QR code on the screen, so you can scan it and we can connect through the LinkedIn. Right? Let's get started. So in the session, we are going to, have the introduction of what is computer vision and why image classification matters in the real world, and what is custom vision, and what are the overview on that, right? And how it works, and how was the workflow and architecture has been developed by the Microsoft team, and what are all the data preparation steps, and how to label it, and how to train the custom models, and how to deploy it, how to evaluate it. And as of in the session, we are going to have the real world use cases, explanations, and the demo at the end, right? So let's get started. So what is computer vision? So the computer vision, which is nothing but it's a subfield of AI that enables the machines to see and interpret the images, and which involves the object detection, image classification, image recognition, and segmentation. So daily examples that we are using in our daily life, the lifetime, right? So we are using the face ID scanning and the Google Lens through the phones, and the self-driving cars, which is in the developing stage in the current world, right? So already we have the Tesla, which is nothing but it's a self-driving car. And here we have some of the importance that of why this computer vision matters. So which automates the decision by making with the images. So if you upload the images, it will automatically classify it, and it can able to develop it, and it can make some own decisions on that, right? And here we have the another use case on the retail, which is detecting on the out of stock products. So if you are placing some cameras or CCTV cameras in your warehouse, so which is telling that detecting the stocks, and which will be letting you that okay, these are all the stocks or out of the stocks. And the main thing is that we'll be using this custom vision in healthcare to identify the tumors in scans. So by uploading and training all the images, all the tumor images, and we will be classifying it. These are all the images that belongs to the tumors, and these are all these set of the some of images. We'll be labeling it as a non-tumors. So if you are uploading any of the test images, it will help you to classify whether the person is having a cancer or not. And the fourth thing is that we will be using this custom vision in manufacturing, and to spotting the defects in assembling lines, right? So if we were producing any cars, so in those cars, like by manufacturing, due to the manufacturing, so there might be defects, or the manufacturing defects can be happen. So to detect that, we can use the custom vision to detect and spot the defects, right? And at last, we'll be using it the security purpose to identify the suspicious activity in the CCTV. To we will not be maintaining all the we cannot maintain, or we cannot be at the time uh, in the important place, or where you have the jewel, or the valuable things that you need to get stored securely. But you can place any camera, and you can train the model to detect the objects, right? If the object is moving, you can able to detect that uh, those suspicious activities are happening in that particular area, and you can set up an alarm uh, to uh, notify you that okay, these are all the suspicious activities is going on. And challenges in traditional image classification. So while getting more benefited in the by using custom vision, we have some of the challenges in the real time. The real time challenges is that we need a large number of data set for the training, and we need a high computational power, for training the data set, and the complex feature engineering. Why? Because like we have to label it according to the images, and that takes a lot of the time. And the last thing is that difficult for non-data scientists to adopt it. Yeah. And here we have a simple example and the explanation for Azure AI and cognitive services. So the first thing is that we'll have the pre-built AI services to add the intelligence to applications, and we have the services includes vision, speech, language, and decision making processes. And the third thing is that the custom vision, what we are speaking, yeah, apart of the Azure cognitive services, which is coming under the cognitive services as a vision. And here we have the key advantage, which is nothing but it's this circumstance and this this environment. It's for all the no code and low code to train the models. What is Azure Custom Vision? So the Azure Custom Vision, which is nothing but which is to service to the service to build, deploy, and improve the image classifiers, and supports the classification and object detections, right? And we can train the model quickly with the transfer learning. And we will be using this APIs and software development kits for the easy integrations. And it is suitable for the developers, analysts, and business, business enthusiasts, and the business aspirants. And here we have the custom vision workflow. So first we'll be collecting the data set first, and we'll be annotating and we'll be labeling the images. Say, for example, if you wanted to classify the image of the dog and cat, right? I'm taking an example that we are going to have in a demo, right? So if you wanted to classify whether the image has the dog or cat, so we will be uploading some of the images which belongs to cat and dog. Let's take 100 of images, right? And we will be training it. And we will be labeling it. Those 100 image belongs to cat and those belongs to dog. And we will be training the model. And for evaluating whether the model is correct or not, we'll be using some evaluation metrics, and then we'll be deploying it. And we can consume the model via APIs, right? Types of custom vision models. So here we have the custom vision models. The first thing is that we have classification models and object detection models. In classification models, we have two types, which is nothing but some multi-class and multi-label. The multi-class, which explains, the one label per the image. So as we say, as we have, see that the one label per image, we are classifying that okay, we can take the flowers, right? We are uploading the flowers image, and we are annotating that it belongs to rose, and we are annotating one image and which belongs to marigold. And this multi-label dataset, multi-label model, which belongs to, we can upload each and every we can upload the bulk images, and we can annotate it as what type it is, right? And here we have the object detection model. Object detection model, in the name itself, we can understand that which detects and localizes the multiple objects in one image. Dataset preparation. So at least collect minimum 30 images per class, right? Recommendedly, like if, how much data you are giving it, it will be a more fuel to the model to predict accurately. And the image should be represents the variations like angles, lighting, and the backgrounds that should be clear, and avoid the biased data set. So if you are uploading the data set, it should be equal, right? It should not be get biased, and the model should not be get overtrained, and we'll be getting the biased results. So split the data set into, the 70 percentage to the training and 50 percentage to the validation and 15 percentage to the test. The data set labeling, which, telling you that it's for use, we can use it for the Azure, we can use the Azure Custom Vision portal to tag the images, and each image assigns to the one or more labels and ensures that the consistent labeling across the data set. And we can, conclude that whether it's a bad labeling, which is equal to the poor performances. The first thing is that, so these are all the process. We have to, create a project. First we have to create the project, and we have to choose the domain. So whether it can be a general, food, and a retail, and we have to upload the image, and we have to tag them and confirm the label, and we can, do the training model. So here we have the training. So we have the two types, which is nothing but it's a quick training and advanced training. The quick training, which, telling you that it's a fast, and which will, create some low accuracy. Whether if you are, providing with the low number of data set, we can, we can choose the quick training. But if you are, having a more number of data set, with, the large number of countable, larger number of counts, so you can choose the advanced training, right? So it's an iterative process that if you are doing some training and you have to test it, and we have to improve it. So that's a good practice. And we can use the transfer learning models under the hood. Model evaluation. So we will be having three metrics. Which is nothing but it's a precision, how much the the model is predicting precisely, and we'll be having the recall evaluation FN score to have the models, to judge the model's accuracy, and the confusion matrix, which helps identify the misclassifications. And last, we have the compare it, iterations to choose the best model performing, right? And here we can improve the model accuracy by using these, by following these 4 points. The first thing is that add more diverse data, right, at different conditions. So for example, if you wanted to classify the image of the dog should be, in the position of sleeping, or it should be standing, and it should be in a side way. So by uploading these images, okay, the model can understand, it can segment whether it's some dog or not, and use the data augmentations, rotate or flip or crop, and remove the poor quality images. It should not be blur, or it shouldn't be in the bad quality, and retrain the model with the new iterations. The model deployment options. The first thing is that we'll be publishing the model as the prediction API endpoint, and we'll be export into, we'll be using the TensorFlow or Core ML iOS for the, the iOS people. And it's all for the, the accuracy building, and the edge deployment we'll be using for the IoT and IoT connections. So for example, if you wanted to connect the CCTV cameras, which will comes under the hood, right? And consuming the APIs. So if you wanted to build the applications like, for the image classification and the image recognition, we can use this best API endpoint to connect in our code, and we can consume it. And here we have the sample code Python. So this is the structure. We can understand that we have splitted it for the easy understanding. So first thing is that we'll be importing the request, and we'll be using the the prediction endpoint. We'll be having the prediction and the training endpoint. We'll be using the two endpoints. So we'll be using the prediction endpoint first, and right? We'll be having the headers for the prediction key, and we'll be uploading the API keys for the prediction, and the content type, what should be the content, and we'll be uploading the sample image that we need to get test. So we'll be using the with open, and we'll be uploading it as an image, and we'll be getting the response by using the post endpoint request. And at last, we'll be getting the response in a JSON. So So this is the thing that we are going to do in a demo, right? I have developed an demo walkthrough code, so we can hop in that. Before getting into the code, let me tell you that what all the security and the responsible AI is, right? So ensure the data set that does not contain the sensitive or the biased content, and it should monitor the predictions regularly and use the feedback loop for the retraining and follow the responsible AI principles. Like we have the six principles, but I have denoted here the topmost three principles, right? Here we have the fairness, reliability, transparency, but we have three more. The pricing tier, which is saying that we have pricing tier, uh, which is having the free tier. We'll be having a limited training hours per month, and when it comes to the paid tier, you can get bill per training hour and bill per the 1,000 predictions. Here we have the real world use cases. So in this real world use case, the first thing we have is that the retail. In retail sector, we have the shelf monitoring for product tagging. So a simple thing is that we'll be using the edge computing, right? We'll be using the combinations of IoT and the AI so that we can able to manage the goods, right? Whether the goods are getting emptied, it should be get notified to the managers, and it should be get order. It should be ready to order. And the thing is that we are using in healthcare for disease detection in X-rays. So we'll be training the model with the more number of X-rays, X-ray images, and we'll be classifying it. We'll be tagging it and annotating it. And it we'll be training with the more number of large number of data set to for the better accuracy. And the third thing is that agriculture to detect the pest and disease identifications. And fourth thing is that manufacturing, the quality inspections, whether the quality is above the par or the below the par. And the fifth thing is that the smart cities for traffic and crowd monitoring. Like we in the cities on in the smart cities, we used to have the CCTV cameras, whether the driver is wearing the helmet or not, for preventing the accidents, and for monitoring the traffic, which is very useful for the smart cities. And here we have the success stories of the custom visions. The first thing is that the Ferrari, so which detects the defects in racing car parts. So Ferrari is one of the customer and one of the client of custom vision, and the Uber, which recognizing the objects for the ride sharing safety. And the third, we have the Microsoft vendor, which comes under the beats, and we are using it to for the crop disease monitoring and the pest detections, and the SME using the AI without data science streams. Okay. Here we have some of the key takeaways that Azure Custom Vision, which is in a quick and scalable images, and which is helpful to classify the build the classifier, and it works well with the small data set, and even with the the small data set, it can get trained well and bring up the results in a more accurate. And it is easy to sorry it is easy to integrate with the apps and the code by using the low code and no code for the fast adoption for the businesses. And here we have the last key takeaway. We can enable the practical real world AI solutions in our with the minimal guidance. Before getting into the queries time, let's get into the code, and let me tell you that how it works. So let's get into the Azure portal. Yeah. So this is the Azure portal. Let's ask for the signings. Just a minute. So here we landed up. So here I'm using this Azure AI Hackathon, sorry, AI Hackathon resource groups, and I have deployed it, the custom visions. So here you can see the Azure AI services. And if you wanted to, the deploy the model, you can go and deploy the visions, right? And here I have already deployed so that we can use this model. So for creating any of the models, you can just click to create, and you can search for the vision. So here we have the custom vision. We can create it. So here it will ask for the whether it is only for the prediction or training. We can use it for the both, right? And here we have the pricing tiers. So here you can set for the standard, and it will use for the 10 transactions per second. And you can set up the name and whether the prediction pricing tiers as well, right? So better I will be using the existing one. You can click it, and you can ask for the review, and you can create it. Okay, so if you take some that, that's why I'm getting into that. Right. So this is the I have recorded, right? And I have the keys and endpoints. So this keys and endpoints will be using it on code. And before getting to the code, I want you to get understand how this submission works, and how we are put the images, and how we are running the images, how we are tagging it, and how all of these things are happening. So here we have the ways we can able to do it in submission well, or we can, if you want to build, if on your own, you can use the code, and you can use the APIs. You can use this APIs, right? Here we have a simple portal. Let's click and enter. So it's running the projects. So here I have two projects, so three projects, right? So let's see on this processes classifiers. So here you can see I have uploaded 60 ads, images, and 50 documents. Right? Before that, I just build how to create a project, how to create a new project. Here you can see that the blog, scan, aspire, and yeah, you can search the resource for that what you need. And here we are going to classically we are going to do the object direction. We'll be using this next weekend. And we are just going to upload our images, and we'll be using single pack of the image. And one is that the channel, right? So we post the images. Let's add. Here I have have the data set. So here in this I have I have the test set and training set. So let's do the test set. Sorry, the training set. I have the calculators like 60. So what I do is that I will be uploading all these images. If you see this image, it's all wow. Um, different rotations, different crops, and the different positions of cat. Right? You can see the woman is carrying the cat in besides her. And see this cat image which contains is beyond the set. And and here you can see the image of the woman who kisses the cat. Right? So what we can do is that we can click all, and we can it is asking for tags. So I would say that it's a tag image. Okay. The things that we have uploaded and we can start the training. Before that, we have to upload the dog images, of course. So we can add the dog images. So likewise, the same the process that we have done for the cat, you have to do for the dog. So here you can see the image of the dog. Let's say get all and then let's drag those images called dogs. Here we have upload. So let's say after the process we have method. Let's see. Here we have two options. This for quick training and the advanced training. We're using the quick training options to train the model for the model. We have the small and the quick this data set we can upload. We can use the training. So it is taking some time. So that we'll be using a beautiful model that I have developed and we can use those projects. So this is project that we have developed. Okay. And here we will have the option for the quick test. So let's say you click a test. I have to know variable that you want to predict. So let's go to the test set and you can pick one random image and let's ask this to the custom vision whether it is predicting or not. Right. So let's go to the test set and I am going to select the image as either no, we are not picking or selecting the ring image, we are just going to upload the test image which is not in the training set. Right. So here it is indicating that this is 99% of the candidate dog. And yeah, it's looking good. So let's try one more image with the cat. Image. That is a 99.9% and we so here we have with the classifications and the no using the convention, but we can develop our own the application by using this API. So here you can see the six options that you can have with IDs and we have the keys and endpoints and the ID. So that we'll be using this these parameters to the project. And main thing is the project name. Right? And let's go to the code. So this is the code that we have prepared. And here we have an inset and a test set and yeah. So we have the two files. One file is for the training models and another file is for the predicting models. So first thing is that we have to train model by using the training key, and we have to use the prediction key as well, right? And here what we'll be doing is that we will be public. It's nothing but we have already created a class out that file, and we'll be using that classification that multiply, right? And we will be tagging it, whether it's or not. and cat, right? And we'll be uploading the images of both data set. So we are saying that it's the image of the image path, right? Image data path. So this is the data path that I have made, and we are including it as a cat tag, and we are typing it as a dog, and we are uploading the path, file path of data set. And we will be training model in this section, and we will be editing it, and we will tell you that whether it is edited or not, right? And after that we will be it will tell you that okay, applications and the rating has been completed, and next we will then bring into the predictions. And in the predictions, we will be uploading, we will be using different endpoint which should be and we'll be using this project ID, what you have seen clearly on the screens, right, and screen options of classification, and we'll be using this machine, right, and we'll be using this prediction, right, and we are in the position to classify that image now. Let's tell you that, okay, first open the image and the right by using the classification and tell you that, and it will tell you that that's the cat, right? And it will, predicting the probability. And then if not, it will be giving the expectations and it will go with the camera, right? So let's say to run. So before say run, I'm just operating the run image of the dog or cat, right? I'm just doing this and say okay. Maybe the category and it is telling you that the percentage of the property is cat. Sounds good, right? So here, likewise, you can develop your own applications like images and object directions. So we will be talking about direction in the next sessions, right? So if you have any doubts, you can raise your hand and you can ask it out. Let me stop sharing screen. So if you have any doubts, just you can glance and shoot your questions. If you have any doubts. All right, I will take it as now. All right. So thanks for joining the session. Just subscribe to the JAI Learn for the Azure AI videos, and it's a session that we are just conducting each and every Saturdays, and it will be very useful for you people like whether you can be an industrialist, IT industrialist, and you can be a student. It is for free. It's under the no cost, right? So you will be get benefited, and your time is your investment, right? So thanks for joining, and stay tuned for the next session and the next announcements. Thank you. Thanks for attending.